Okay, this is inequalities and it matches up with page 87A in the red Big Ideas book. Um, our internet is not working right now, so I couldn't print this out. But we're going to look at inequalities the same way as we do equations. There's just something that's a little bit different. So this means our answer is going to have to be less than or more than, or less than or equal to, or more than or equal to a number. But we're going to use the same properties we did before. So if we have x minus 5 equals negative 3, we would need to move the 5 because it's on the same side as the variable. So same thing with inequalities because it's saying x minus 5 is less than negative 3. So if we add 5 to the left side and we add 5 to the right side, we have x is less than 2. And one thing that we do with inequalities is we graph them on a number line. And so if we drew a number line out, and I put the number 2, and then 3, 4, 1, and 0, x has to be less than 2. So that means it can't be 2, because that would not be true. So when we're graphing it on the number line, we have 2 right there. And then I usually use a colored pencil or a highlighter to show this because it's sometimes hard, especially on the worksheets, to just darken over here because this is where x is less than 2. And we're going to leave that circle open because what that tells us is it includes all the numbers to the left, but it doesn't include 2 because it had to be x is less than 2. So that would be one example right there. And it's the same thing when we have fractions and such. So right here we have, this is number 7, this is on page 87B, and it has b divided by 8 is greater than or equal to negative 5. So just like if this were b divided by 8 equals negative 5, we would need to get the b by itself. So that would mean multiplying by 8 and also multiplying by 8 on the other side. So this allows us to just have b is greater than or equal to, and then if we look at 8 times negative 5, we would get negative 40. So b has to be greater than or equal to negative 40. So our number line that would be drawn with a ruler, I usually put negative 40 or whatever my number is on the inside. And then I can do like negative 36, negative 34, 32. I'm counting each of them by 4. And then negative 44, let's see, negative 42, and so on. So with this one, because it's greater than or equal to, we're going to color in the whole circle because it could be negative 40. And then if we think about, okay, what side is greater than negative 40? And this one's going to go to the right. Some people, if you write it x is less than 2, it goes this way. This looks like the tip of the arrow. B is greater than or equal to negative 40. It matches up with this arrow. That only works if you write your letter first. If I wrote it the other way, negative 40 is less than or equal to B, it would be different. But generally, the variable is written first. So those would be 2 examples of that. It gets to be a little bit different. I'm going to make up this problem. This is number 10, but I'm going to change something. So we have to have 63 is less than 9q is the problem. I'm going to make it negative 9q. Because when we have multiplication and division with negatives, it mixes it up a little bit. So to solve this, if it were a regular equation and not an inequality, we would have to divide by 9. Negative 9, sorry. Same thing. We divide this one by negative 9. Dividing by negatives switches our sign. So right here we have 63 is less than. 63 divided by negative 9 is negative 7. This was less than. Now it's going to become greater than because we multiplied or divided by a negative, and then it's equal to q. So if negative 7 is greater than q, that also means that q is less than negative 7. And we just reverse the order of it. So if we graph this and we have -7, -8, -6, it is not equal to. So open circle, and then we have it's less than -7, which means less than would be to the left. And that would be our example right there. Same thing applies when we're having to multiply by a negative. So if I had, I'm going to make this one up. If we had x divided by -5 is less than or equal to 3, we would have x divided by -5, so we would have to multiply by -5 to get rid of it. And if we multiply by -5 on this side as well, x, and then this was less than or equal to, now it becomes greater than or equal to -15. So on the number line, we have -15, and we could put -10, -20, -5, because the numbers get bigger going that way, and it's equal to as well. So we have x is greater than, we're going to shade off to the right there. Okay, so this is on page 87D. It is example 4. And just to like walk you through this is the same exact thing as equations, we just have that graphing piece that's a little bit different. So if we have -3x plus 2 is greater than 11, we know that this is a variable, this is a constant, and this is a constant. So we would need to move the 2 because it's on the same side as the variable. So that would be subtracting 2 and subtracting 2. And so we have -3x is greater than 9 because we had to subtract the 2. This is a -3 multiplied by x. So to solve this, we would need to divide by -3, divide by -3. Because this is a negative, we know we have to reverse our sign. So we have x was greater than, now x is going to be less than -3. And on this, if we do like -6 and we do 0 right here, it's not equal to, so it's an open circle. And if x is less than -3, it has to be to the left as well. So it's the same thing as equations as far as the solving piece. We just need to be careful with the multiplying and dividing by negative numbers because that will change the direction of our sign.